An ellipse that is elongated along the x-axis has two foci located at x is equal to plus or minus c, where there's a relationship between that and the a and b parameters is a squared is equal to b squared plus c squared. How does this relate to the physics of an orbit in our solar system? So what we're talking about here is the foci, like for this ellipse right here drawn in an xy coordinate system, might be like, I don't know, maybe one of them would be like right here. I'm only approximately going to draw this in. One of them could be right here. And like those two spots would be located, like this would be at x is equal to minus c. This would be at x is equal to plus c. Kind of the relationship here is like you said, like, well, hey, this is again, it's c minus c. But you could kind of say like, well, check out this triangle right there. That triangle would have two legs with lengths b and c respectively, and it turns out this hypotenuse would equal a, which is also the distance from the center of the ellipse all the way out to a, which I'm trying to remember, is that called the semi-major axis or something like that? There's a semi-major axis, semi-minor axis. Anyway, hopefully I got that correct. It's the reason I don't teach math, right? Anyway, that's all really, really interesting. But does that answer this question at all? The answer is no. I've been talking about math here. But it says, how does this relate to the physics of an orbit in our solar system? And the answer is none of this really does. But the one thing that is relevant, and I'm not, in this class, I'm not going to prove this or derive this kind of stuff. This is just information that I think is good for an educated person to know about the relationship between orbits and the actual physical characteristics. And in particular, if this is an elliptical orbit in a real solar system, the sun it is orbiting around is going to have to be at one of those two foci. And like I said, that's a result that is way beyond, I think, the level of this class and probably quite a few other classes too. I mean, I've seen it done, but it's a pretty advanced result. But it's kind of cool to know that the sun always has to be at one of those foci. In that sense, that knowledge, I think, is kind of part and parcel to Kepler's first law about elliptical orbits. So let's check it out. It says, for a planet orbiting the sun in our solar system, one of the foci of the orbit corresponds to the center of the sun.